All right, here we go with lesson 3. This is one that we will be using a lot moving forward. It's not hard, it's just definitely used a lot. Evaluating functions. So we've actually done this before. We just didn't call them functions. They were expressions that we evaluated. And all we did was we replaced the variable with a number that I told you. So for this first one, 4x plus 2, for x equals 10, you just put 10 in for x and figure out what it equaled. So 40 plus 2 gives me 42. Second one, you do the same thing. You put 16 in for y. You follow your order of operations, and you come up with a number. 16 minus 4 first, because it's all part of the fraction. 12 divided by 3 gives me 4. Okay? So on the first one, when x was 10, the y value or the output was 42. When y was 6, in the second one, the input was 16, the output was 4. Okay? And I use those words on purpose because I want you to see that that's all we're doing today. It's exactly what we just did. Putting something in, and then the function is spitting something out. Now you got to understand function notation. It's not hard. It's just a little different. A function rule is an expression that represents or describes a function. So we need to write equations, which we've dealt with all first semester, in function notation. So to write an equation in function notation, you only need to change the y to f parentheses x. Now, this is not a new variable. The f is not a variable. Please understand that. Whatever is there in front of f, it can be f, it could be g, it could be m, it could be w, it could be any letter. That's not a variable. It's the name of the function. That's all it is. It's representing a name. So if I'm going to write this equation in number 1, y equals 3x minus 2, if I'm going to write that in function notation, all I'm going to do is I'm going to replace the y with f of x. So I have f of x equals 3x minus 2. And for the second one, it's as simple as f of x equals negative 4x plus 6. That's it. Now, what do we do with that? Let's keep going. When evaluating a function, you will see f of x be replaced with something like f of 2. And notice how I'm saying that. I'm using the words that I want you to say. F of x, f of 2. This simply means that you need to replace x, or the variable, with the number 2 in the function rule. So in this case, it's 2, but in general, whatever number's in there, it could be f of 5, it could be f of negative 3. You're going to replace x with that number in the function rule. So essentially, it's what we did at the very beginning of these notes. So f of x equals negative 5x plus 25. Find f of negative 2. All that means is I'm taking negative 2 and I'm putting it right there. So negative 5 times negative 2 plus 25. So the input is negative 2. Negative 5 times negative 2 is 10. 10 plus 25 is 35. The output is 35. Now I could write that as a relation, which is an ordered pair. When I put negative 2 in, I got 35 out. Okay? Let's do the next one. F of 10. So I'm putting 10 in for x in this function. So I get 10 squared minus 4. 10 squared is 100. Minus 4 is 96. So if I'm looking at this as a relation, I got 10 as my input. 96 is my output. All right. Now 3 and 4 get a little more tricky because there's 2 functions in these problems. You see we have f of x and we also have g of x. So f of x is one rule, g of x is just a different rule. All right, so f of 8 means I look at the f function and I put 8 in for x. So the negative is there. I'm replacing x only. I'm not replacing negative x. I'm replacing x with 8. And then I'm going to put a negative in front. That's like a negative 1. Negative 1 times 8 is negative 8. Plus 2 is negative 6. So that portion, f of 8, is negative 6. Then I got to go to the g of 3. That means I'm going to go to this function, and I'm going to put 3 in for x. So I'm going to have 3 times 3 plus 4. So that's 9 plus 4, that's 13. And then what I do with those is I add those two values together. So negative 6 plus 13 gives me 7 at the end. Okay. Number 4, f of 2 minus g of 16. Let's do the f first. So f, I put 2 in for x. That's 5 times 2. Hopefully you're noticing that when I replace the x with a number, I use parentheses. It's going to come into play when you have exponents for sure. All right. Right now, it doesn't really matter too much because you're not dealing with exponents on any of these. Okay. So 0.5 times 16 plus 7. 0.5 times 16 is 8 plus 7 is 15. And then what do I do with those two things? I subtract them. So 4 minus 15 is negative 11. We're all done. Okay, let's go down. Let's go to the back page. Evaluate the function rule to find the range of the function for the domain -4, 0, and 3. In other words, I've given you 3 inputs or x values, and I'm asking you to give me the 3 outputs or x or y values that go with them. So we got to basically do this 3 times. So here we'll split it up. -4, I'm putting it in for x. Now these bars here might be the first time you've seen them. Those are absolute value bars. We're going to graph these in the next lesson. So make sure you understand what I'm doing here. All that means 2 times -4, I'm going to multiply those. That's -8. Once I get a single number inside the absolute value bars, I do the absolute value. So what that means is, how far is -8 from 0? Well, it's 8 units. Not negative anymore. It's 8 units from 0. Okay. Well, then I subtract 15 to finish it up, and I get for the first one, -7. That's the first one. Second one is 0. So 2 times 0 minus 15. So 2 times 0 is 0. Now, the absolute value of 0 is pretty easy. How far is 0 from 0? Well, it's on 0, so it's nowhere. It's just 0 minus 15. So the second one is -15. And the third one, put 3 in for x. 2 times 3 is 6. The absolute value of 6. So how far is 6 from 0? Well, it's 6 units from 0. So the absolute value makes whatever's inside the absolute value, once it's simplified, it makes it positive. So if it's already positive, it doesn't do anything to it. So in this case, it just stays 6. So 6 minus 15, -9. So my range ends up being -7, -15, -9. Okay. And that's it. Now you try it. Try pausing the video. Get the 3 x values, or sorry, the 3 y values from the 3 x values given to you. Okay, hopefully you tried that. Let's do them right now. So I'm going to put -6 in for x. Okay, -6 minus 1. I do that first. That's -7 divided by 2. You could just leave it like that. I'm sure some of you did -3.5, which is also fine. If it says leave it as a fraction, make sure you leave it as a fraction. But yeah, 3, put 3 in for x. 3 minus 1 divided by 2. So 3 minus 1 is 2, divided by 2 is 1. And then the last one, 9 minus 1 divided by 2, that's 8 divided by 2 is 4. So my range here is -7 over 2, 1, and 4. Okay. All right. Now I am basically teaching you the next lesson here. kind of. There's gonna be a little bit more to it with the next lesson, but you're gonna complete each of the following tables for the given function rule. So I'm giving you a function. This idea is gonna be used in the next lesson, so it's a good idea to understand what is happening. All right, so with part A, fy equals 1/2 x minus 3. If you remember that from first semester, that's slope-intercept form. You could graph that using the slope and the y-intercept. We're going to graph it using a table of values. It's going to give you the same thing, but I just want to show you how it works. Table of values, you're going to have to come up with the x values. I gave them to you right here. So I gave you the x values of -4, -2, 0, 2, and 4. Why those? We'll talk about that on the next lesson. Okay, so I'll put -4 in for x. That's all I'm doing. Basically doing an evaluating of functions 5 times. So 1/2 of -4 is -2, minus 3 is -5. So the y value is -5. I do the same thing with -2. Half of -2 is -1, minus 3 is -4. Half of 0 is 0, minus 3 is -3. Half of 2 is 1. 1 minus 3 is -2. You might know the pattern. Half of 4 is 2. 2 minus 3 is -1. So you're doing an evaluation of functions 5 times to fill in this table. You're going to do the same thing with part B. Now, part B is a little trickier. It's got an exponent. It's got that negative as well. Think of that negative like a -1. So it's like -1 times, and I use parentheses again, -2 goes in for x, and that's squared plus 5. So the first thing I'm going to do is I'm going to do the exponent. Order of operations says the exponent. So the -1 hasn't been touched yet. -2 times -2 is +4. Now I'm going to multiply -1 times 4. That's -4. Final thing I'm going to do is I'm going to add 5. So -4 plus 5 is 1. All right, now I'm going to do the same thing with -1. So -1 times -1 squared plus 5. You're going to want to multiply -1 times -1. A lot of people want to do that. Don't. Exponents first. -1 squared is +1. -1 times 1 is -1. -1 plus 5 is 4. 0 is not too bad. -1 times 0 squared plus 5. Well, 0 squared is 0. 0 times -1 is 0. 0 plus 5 is 5. Let's go do 1. -1 times 1 squared plus 5. 1 squared is 1. -1 times 1 is -1. Plus 5 is 4. And then the last one, put 2 in. 2 squared is 4. Times -1 is -4. Plus 5 at the end gives me 1. I know it takes a while, but it will help you graph tomorrow. So that ends this video and ends the videos for the week.